Hey, we're back, and today we're going to do something that's a little bit more technical. I thought it'd be fun to recreate the compass that you might see in Skyrim or PUBG, any open world sort of games. And I've got another little care package here for you guys that you can find in a download link in the description with just like a marker and obviously some compass points. It's quite a high resolution, 5400 by I think 60, so fairly big image. But there's really not much to it, so let's just jump straight in. I guess to start, we're going to need a simple widget. Call it compass. Compass hard. And we'll open it up and we'll get to work. So here is our canvas. Now, we don't want it to just like stretch outside the bounds of the screen, so we're going to use another canvas and just embed it in our main thing. So let's set our size. We'll set the size to 1000 in X and 60 in Y. Although I will double check. Yep, 60. Cool. And that'll be positioned in the center of the screen somewhere. We'll anchor it to the middle. And then what we need is to import our images. So just grab the 3 files, or just the 2 files. We'll do the objective marker afterwards. So here we have our oh, come on, where are you? There we go. So this is our marker. Just remind myself what its dimensions are. 23 by 120, 23 by 120, and this is 5400 by 60. And we want to put our dots, our compass points, in the canvas. So just click and drag onto our embedded canvas here. And then with our canvas selected, let's head down to clipping and change the clipping to bounds. That way, as you can see, our compass is staying within the bounds of the canvas. As for our marker, just place it somewhere central. In fact, we'll make sure that our anchors are all set up properly. And our marker here, centered in the middle, and we'll put it right up in the center of the screen there. Just like that. And that's pretty much it. And yeah, we'll rename these things just so that we know what we're doing. So these are our points, and this is our marker. All right, then we can move on. So the first thing we're going to do is we'll just compile and save. We'll find our third-person character and open that up. Where are we? Okay, so we'll need a begin play. Begin play. And we just want to put the compass on the screen. So just create widget, select compass, compass HUD, and then add to viewport. And that's done. And that's really all there is to it to get the compass to work. So when we open up, when we start playing the game, we can see it there appearing on the screen just as we intended it to. Next thing though is to make it, actually work like a compass. So back in our compass HUD, we'll head to the graph and we'll start getting to work here. First, we'll need a new function. This one will be called set direction. And we're going to need to pull in our the camera from the player. We'll save that actually. We'll go back to the event graph. And we'll come off the event construct because we've got to establish what it is that's exactly going to be manipulating the compass direction. And for that, we're going to use the camera in the third-person character. So we're going to cast to third-person character. We need to get the player character. Wow, if only I could spell today. Get player character. Plug that into the object. And we'll need a variable to go forward with. We'll call this one our rotation. And that needs to be a camera. So over in variable type, just type in camera. Camera actor is what we want. And we want to set it here. So as third person character, we want to get the follow camera. Get follow camera. and plugged it into our, oh, what's gone wrong? Camera actor, might need to be a camera component. Let's go with an object reference, our camera component. And we'll drag that in to set it. There it goes. That's how that plugs up. So it's a camera component, not a camera actor, because it's a component of our character blueprint. Should have known that going forward, whatever. And then from here, we need to call up our function. So it's a set timer by function name. And this is where we type in our set direction. So we'll put in set direction. Make sure that you get this absolutely right. Like the spelling needs to be spot on, which appears to be a problem for me today. And the time to 0.01. So it's updating very, very quickly. Now, let's head back to our function and build this one out. So all this function's doing is just setting the X position of the is that position in viewport? I don't think that's right. No, it's just setting the X position of our compass. So we'll drag our points in. We need to get that. Then we need to reference it as a slot as canvas slot. And set its position, set the canvas slot position. We can split this 2D vector so that we get the actual X and Y. And then we need to do some boring maths. So grab our rotation camera, because this determines the direction that the compass faces. And we'll get the world rotation. We need to split the rotator, because we don't need the entire, like the whole vector rotation, just the Z value. And now here comes some boring maths. We need to multiply float by float, multiply it by -1, because this will return a negative value. We want to multiply it by 10, because the values are very, very small. And then we want to subtract half the width of our compass points, which in this case is 2700. If this is at all confusing, just see how this looks when you don't do this maths. Like, trust me, you get some weird results. And that should be all there is to it. And we can test this out by hitting play. Oh yeah, and see the compass is sort of dropping down. I noticed this when I was pre-recording. If you just set the Y position to just a straight up -30, minus half the width, and there we go. There's the compass working just fine. Excellent. So I'll do a quick recap, and then we'll move on to doing nav points. So over here on the event graph, we're just casting to our third-person character to grab the camera, set this as our rotation point, and then setting a timer by function name. And that timer is just simply setting setting the direction, just the simple X value of the compass points, and updating it every 0.01. And it loops back on itself. And the result is spot on perfect, and it's seamless. It'll seamlessly go a full 360 degrees. And just an example, if we just set this back to 0, this is our final subtraction value. As you can see, like strange things happen. It doesn't line up. It doesn't slide around in a way that makes sense. So half the width of your compass. Next up is making nav points. So there are a lot of different ways to pass data between different blueprints. I'm just going to go with the super simple solution, and that is to come over to the third person character and make a new variable. This one, I'll just call it nav point. It needs to be a vector, and we don't have to set it as anything. Just make sure that it's there. Make sure that it's here, and we'll set it to public as well, just cause. Then we'll come back into our editor, and we'll make something like a nav point blueprint. So just make a new blueprint class, just an actor. Let's call it objective BP, and we'll open them up and do some stuff. So all I'm going to do here is just set a static mesh. I'm going to use the matte preview mesh. There are two. There's a map preview in the starter content, and there's one in the engine content. I prefer the engine one. It's just a little bit classier in my opinion. Yeah, I just like a little bit more. And we can even make a material for it. just very, very quickly. Here's just a material. Objective mat. Open it up. I'm going to make yellow as base color. Literally, that's it. And then we'll just drop it over here. Objective material. A nice bright yellow. And over in the event graph, we can we need to set the location of this actor as our objective. And in fact, what I might do I'm just going to reduce the size of this guy. I knew that would happen. Let's make it a little bit smaller so it's not so big in the editor. I've noticed that they're quite large in relation to the size of the player. So in the event graph, we'll go off the begin play. We want to cast to the third person character again, or whatever your player character is named. We'll get the player character. Oh, that's the wrong one. Get player character as the object, and as the player character, we'll set the nav point. We'll connect that up to the target, and the nav point in this case is going to be the actor location. That's this actor, the objective blueprint. And that's all there is to that. So hit compile and save. Then in the editor, grab your objective and put him in the editor somewhere. So there he is, just off to the side. At the moment, there's nothing going on because it's just sitting there. But we can now go ahead and make our nav point work. So head back to the compass HUD and we'll get started. We're going to need another function, this one being check nav point. And to check the nav point, we're going to cast back to the third person character again. Cast to third person character, get the player character, and we need the nav point. So we'll get our nav point. And this is just how I'm moving data between different blueprints. So the third person character has the actual variable. The objective that we just made, the map preview mesh, sets the nav point to its own location. And then in the HUD, we call on the third person character to get that nav point, which has now been set by the objective. Hope that makes sense. Okay, so we'll need a return node. Add return node. Perfect, just so we have our closed function here. And we'll need our rotation, our camera. So we'll just get this, and we're going to need some values here. So we'll get the world location. We'll also get the right vector. And we'll get the forward vector. These just determine certain things about the component in the world, like where it is, which way it's facing, what its rotation is, that kind of thing. Because we're going to need to get the products of some of these values in order to find the solutions that we're looking for. So from the world location, we'll get the find lookout, the rotation of where it's looking, and we need to reset this to the target. For the start value of this is where our nav point is. And from here, we'll get a rotation from X vector. And we need the dot products. I don't think that's... No, that's not right. It's the... normalized 2D. We need to normalize it as a 2D vector, just like that. Yeah. And then when we drag it in, it'll convert on its own. Perfect. And we'll need more of these. So we have to convert these two values also to 2D vectors. And then we need the dot product. Dot product 2D. We'll need two of these. And we want the result of this normalized 2D as the second value. I know it's a little bit complicated, but I will go through this. I'll go through this as I go. So we'll have to divide these two values. That is the right vector and the forward vector, or the dot product of those two values from the world location of both of our points. Divide them from each other. And then we need to multiply the value, because if we don't, then the nav point isn't going to move very far on the compass. It's going to be sort of moving only a couple pixels to the left and right. So you want to crank up these values. I used 700, but your mileage might vary. And from here, we'll just go from the this multiply node, we'll drag it to the return value, and we can rename this. This will be our X position, XPOS. Hit compile and save. Then back in the event graph, we will need to find our event tick, because this is one of those things that has to be updated sort of in real time. We'll grab our check nav point function, and we'll plug that in. I'm just going to make myself some space. And then we can just set position. Set position. Oh, I've done it again. So I might just copy these 3 nodes. Just like that. But we don't use the points. What we need now is to head back to the designer and add our objective. So drag in your objective file. Make sure that it's set right. I believe it's got the same dimensions as the marker, which means it's 23 by 120. That looks about right. And this has to be dragged onto our new canvas panel. So we'll set the anchor to the center. Oh, where did it go? There it is. And we'll just put it in the center for now. It's going to change. So with that established, we can drag it in, plug it into the slot as canvas slot node, and then we're about set. So when we connect up this set position node and hook up the XPOS into our in X position, then hit play. Ah, the same thing's happened again. I think minus 65? Yeah, minus 65. So now, as you can see, the nav point follows the object in a pretty accurate way. I mean, you can tweak these values to get a slightly more accurate sort of representation, but it's working quite well. Although there are problems. Most notably is that if you're facing behind it, see, because the camera is now in line with the objective, it's showing up on the compass, and we don't really want that. But we can fix that. We can make it so that the compass works absolutely perfectly, and here's how. We'll need another function. This one's the check if behind. And for check if behind, we'll need 2 vectors. One for the object, and another one for the camera. And these both need to be vectors. So these are going in the input node, which means that when we call this function, we have to give it these 2 values to in order for them to be dealt with. So we'll get those two values. We'll normalize them both. Simplifies the values, and then we need the dot product from these 2. Dot products, plug that in, and then we have to find the degrees. So when the camera is facing the nav point, like front on, it'll be 0, and it'll be going up and down values as you turn left and right. So then we can call bounds and make sure that it's not visible when we're behind it. To do that, we need an ACOS, and we'll use degrees. So ACOS in degrees, then we need a less than. And in my case, the value here is 140. So if the degrees away from the nav point are less than 140, then it doesn't show up. And we've got to make sure that we add a return node, and we'll drag the result of this boolean onto the return node so that we know what we're dealing with, and we'll call this visibility. Great. Now, back in our event graph, we can call our new check if behind function. Just put it in between these 2. But we also need to find our object and camera values. So go back to our check nav point function, and we'll need the result of our forward vector from the camera, and we'll also need the result from this rotation x vector from the object. So drag them both onto the return node, and we'll name them so that we know what we're dealing with. Camera and object. Man, I am having trouble spelling today. So that's with object and camera. So we're getting those out of our return node, and now they've appeared when we call the function, and we can hook them up in our check if behind function. And obviously the result from this is a boolean will come into a branch set this as the condition. And then for if true, if it is outside of the bounds of my 140 value, then it won't show up. But if it's not, then it does. So we need to duplicate this set position node, get our xpos and plug it into both. Make sure that we have our target set. And all I'm doing here, not a very elegant solution, I'm just changing the y value of the nav point if it doesn't, if it's not inside the visible range. So just set this to any kind of value that's just outside the x value of the canvas. Then we're about done. So let's do a little quick recap before we test it out. So we're checking for our navigation point by doing some very boring maths, finding the dot products of a few different values and comparing them to one another. It's not too complicated, but you might need to tweak values in your own case. We're passing data between the third person character and the HUD. And we're checking if the nav point is behind the character by doing some more boring maths and finding the degrees of rotation away from the nav point. So this should all work fine. Let's test it out. All right, so there's our nav point as we face the object, and when we're behind it, nothing. Good. So when we're facing behind it, there's nothing. This means that the player in game isn't going to be walking directly away from something when they don't know that they should be turning around and going towards it. So this was how to make a compass similar to in PUBG or Skyrim, and the dynamic part about this is that we can move this guy anywhere, and it will change where the nav point appears. You could also adapt this for multiple nav points by adding more vectors to the third person character. You could use a blueprint interface to also pass data between different blueprints. And this can be done with virtually anything. I've just used a simple sort of yellow line as the indicator, but you can use custom images. There's all sorts of things that you could do to change this system, and it works extremely well. Like there's a flawless looping of the compass rotation. We'll always know which direction we're facing. And the nav point works absolutely perfectly. The only thing that you should keep in mind is that, I mean, although the sun is perfectly above me right now, the compass points might not actually align with what is an accurate compass direction. Like, in fact, I think these are a bit wrong. Like the southwest, I don't know. But anyway, that's the Skyrim compass. I hope you guys like this video, and I will see you in the next one. Thanks for watching.